So to solve this question, I'm going to do it graphically because I think it graphically is a little bit more easier and more visual. I think it'll help you to understand better, but it can be done algebraically too. So maybe I can talk about that a little bit as well. So here is the graph of x squared, the graph of the function on the left-hand side. So the x squared graph is like this. And then the graph of absolute value of x is going to be, so it's going to be like this, but crossing this and going this way. And then it's also going to cross this function at this point as well. So it looks like we're going to have, so let me point out the crossing points. This is one crossing. This is one crossing right here, and this is another crossing right here. So we're saying that x squared graph must be less than the absolute value graph. So whichever is on top, that's going to be the bigger one. So I'm going to look for where x squared is less than the absolute value graph. If you look at this intersection point, we're going to compute this in a little bit. So between this intersection point and the next intersection point, which the next intersection point is right here, between these two intersection point, the absolute value is on top, so x squared is smaller. So then I'm going to find these two intersection point simply. So let's just go ahead and find those. So x squared, to find intersection point, I'm just going to set these two things to each other. I'm going to say x squared equals 6x minus 5. We will have two cases here. So one case will be x squared equal 6x minus 5, and the other case will be x squared equal minus an absolute value. So we have to have two cases. So then this is, if you move everything to the left, this is that, and then you can factorize this as x minus 5, x minus 1 equals 0. So this will be x equal 1 and x equal 5. And looks like we will have 1 right here and 5 right here, right? This is 1 and this is 5. We're still going to compute the other one. So the other one will be x squared equals negative 6x plus 5. Move everything to the left. That's plus 6x minus 5 equal to 0. And this is not factorable, so we'd have to use quadratic formula for this, which is quadratic formula is negative b plus minus square root of b squared minus 4ac divided by 2a. So I'm going to use that, which is negative 6 plus minus 6 squared is 36 minus 4 times 1 times negative 5 divided by 2, which is negative 6 plus minus, this is 36 plus 20. 36 plus 20 is square root of 56 divided by 2. This can also be simplified. And when we simplify this guy, we're going to get, so when we simplify this guy, we're going to get two numbers, which one of them is negative 3 minus root 14, and the other one is negative 3 plus root 14, which are this number. So the one is negative is this guy, the positive one is this guy, the point right here, this point right here, which is negative 3 plus root 14. So now I have two possible interval where the black graph, which is x squared graph is on the bottom, right? Which is here. So now I'm writing the solution. So from negative 3 to 14, that's this one. This is the first one. So we need to use a bracket because it's less than equal to the other number, which is this. And then union, we have another one where the black is on the bottom. See, the black graph is on the bottom. So that means the black is smaller than the red one, right? So that's from 1 to 5. So basically from 1 to 5, that completes the solution. So you just really have to find the intersection point and then look at where x squared graph is below the absolute value of the absolute value graph. And that gives you the solution of this inequality.